Hello and welcome! In this lecture we're going to refactor our grid system to support generics. Doing so will allow us to reuse the grid system for our grid-based logic and also for our pathfinding while using two different grid object types. Okay, so here is the grid system just like we've built in the course. So we create a grid placed in our world. Each grid position has a certain grid object and then we can apply all kinds of logic to that position. So in our case for the logic we care about which unit is on there, so that is the data that we store. Here is the grid system definition, and we made all of this, and we made it all work with this specific grid object type. Here is the grid object, which as you can see, we have a reference to the grid system, the grid position, and then, like we saw, a list of units. So we made this class to represent our game grid, but there's many other scenarios where we could reuse this grid system, like for example the pathfinding. However, we don't want to end up with a massive grid object that does tons of things. We don't want to include here both the game logic and the pathfinding logic. We want those systems to be nicely separated. And we also don't want to duplicate this entire class. That would make tons of code duplication. So we want to reuse most of the grid, but pretty much just use a different grid object type. So that's where generics come in. Let's begin here on the grid system definition, and let's make it use generics. And for the generic type, let's call it tGridObject. Now, of course, we need to change all of the references of grid object to tGridObject. So let's find and change all of this. So change that one, then over here, then over here. Let's see also down here, grid object. And yep, that's about it. Okay, so we changed all the references. We have an array of our custom grid object type, and we're doing all the logic with that custom type. However, now over here, we also see this error. Using a generic with no constraints at all means that we can use any type. However, here we are using new to create our object, and since we have no constraints, we have no guarantee that we're going to use this class with a type that can be created with new. So one solution to this problem is to add the constraint. So let's add the constraint where tGridObject has to implement the new constructor. And if we do, this does work. However, we still have an error. The issue is that when we use this constraint, it only lets us use a parameterless constructor. So here we are passing in two parameters and we cannot use that with that constraint. Sadly, C# does not allow you to use new with multiple parameters. You cannot make that type of constraint. So we cannot use this solution in this scenario. However, what we can do is use the other awesome C# feature, delegates, to essentially receive a delegate that creates our object. So on the grid system constructor, we receive all of this. And then afterwards, let's receive a func. So we need to add using system. So here let's receive a func, which is a delegate that returns something. So we receive this, and let's use the same parameters that we were using over here in the constructor. So we've got a this, so that is a reference to the grid system, and then the grid position. So on the func, let's receive those. So the first parameter is a grid system of type tGridObject. For the second parameter on the func, that is a grid position. And finally, the last parameter, this one is actually the return type, and the return type will be of type tGridObject. So let's call this one the createGridObject. So with this, we are essentially bypassing the C# limitation on the generic constraints. With this, we're going to essentially pass in a delegate which will create our object. Then down here, instead of using the constructor, let's call our delegate. So we call our delegate and pass in the same parameters. Okay, so that works. Everything else is the same. Down here, there's still an error with the debug objects, but let's worry about that in a bit. So we've changed this, and of course, since we changed the grid system constructor, then let's go into the unlevel grid to see where we are creating it. So let's find the unlevel grid script, and let's go up here. First of all, we have our definition. And here, let's create it using the exact same grid object that we were using previously. So to do that, we just use the grid system using the exact same grid object. That's it. And then down here on the constructor, we construct it, and then the final one, we have to pass in our delegate. And for this, we can even use a lambda expression or an anonymous function. So let's pass in a delegate that is going to receive a grid system of type GridObject. For the parameter, let's call it G. Then let's receive a grid position. So these are the two parameters. And then for this one, we're going to return a new grid object. So GridObject. And in the constructor, let's pass in the grid system and the grid position. And on the grid system constructor, let's also pass in the grid object. And also we forgot to remove the constraint, so let's remove that. On the grid system, let's get rid of this constraint. Okay, so now back in the level grid, and over here that error has been fixed. Okay, the only final thing we need is on the grid object itself. It still expects just a normal grid system, so let's go there. Here on the grid object, just receive a grid system of type grid object, and then here we receive of type grid object. Okay, so this is solved. The level grid is also solved. The final thing is just on the grid system here for the debug objects. This one, the grid debug object that we made, still expects just a grid object, whereas here inside the grid object we're using tgrid object, so these are two different types. We're actually going to refactor the debug objects in a bit when we want the pathfinding to display different data, but for now let us just forcefully cast this into the grid object. Okay, so that's it. So ideally right now everything should still be working exactly the same as previously, however the code is now using generics. Here in the editor we have no errors, everything compiled, so let's play. And here we are, we can move, we can shoot, we can take all kinds of actions, and everything still works perfectly just like before. Alright, awesome. Okay, so here we refactored our grid system to support generics. Doing so means we have a really nice class that we can use with any type, and this is going to be super useful when we reuse this grid system with the pathfinding, so let's begin doing that in the next lecture.